So, hi everyone, thanks for joining our session. I am Marek, and here is me with my colleague Vaclav. We are big data engineers located in Prague, Czech Republic, and we work for ABSA. ABSA is an Pan-African bank providing its services in 12 African countries. And currently, our bank is going through a transformation to become a purely data-driven organization. To achieve that goal, we heavily utilize Apache Spark for data processing and data analytics. I would like to tell you something about our big data R&D team in Prague. So our big data R&D team focuses on finding and filling gaps in Hadoop ecosystem, mainly in terms of highly regulated organizations as we are, as banks. Plus, we are super excited about developing open source code. So we actively contribute to Apache Spark, and we get open sourced some of our internal projects. So far, we have open sourced 4 of them. The first one is ABSA. It's a serialization and deserialization library for Avro to Spark structured APIs. The second one is Cobrix. It's a Spark data source for COBOL. The next one is Atom. It's a library for measuring data quality. And the last one, but not least, is Spline. It's a data lineage tracking tool for Apache Spark that we introduced at the last European Spark Summit. This presentation will be about possibilities how to extend Spline for tracking the lineage of Spark streaming applications. Before I do that, I would like to define what we understand by lineage of structured streaming applications or streaming applications. So assume that you work with some colleague, and the colleague gives you a link to a data source with stream data. And he tells you just, let's say, this is just a Kafka topic. That's what you know from your colleague. But before you start consuming the data, you would like to know some more details about the data, maybe how data actually were transformed, what applications, what Spark applications were involved in during the transformation of the data, what are the origins of data, and also what are the details of applications that are involved in the processing. And also, very important aspect is to know, let's say, what is the schema of the data and what format represents the data before you start writing some parser and so on. So actually, those aspects that I mentioned, those are covered by Lineage. So actually, with Spline, we have already solved that problem for Spark batch jobs. But I would like to mention that our key motivation for creation Spline was to make Apache Spark BCBS compliant, and mainly to fulfill the requirement for clarity. So it's a business expression. So in a nutshell, I will tell you what it means. So we as a bank, we are obliged to our regulators to provide them data about how we do our business. And also, regulators want from us, let's say, to provide evidence how the data were calculated. We do that by providing lineage information. So, but actually, how we could do that? Let's say people like regulators, those are business people. They don't understand code and so on. So actually, we exposed in user-friendly interface to regulators, and they can explore like a logic of the Spark applications. Since in our institution we also have, let's say, internal business people, so actually we leverage Spline for the communication with business people, mainly if they have some new requirements, let's say for our ETL applications, and they ask, let's say, maybe to change something. So we implement it, and let's say with Spline, they can double check whether the new feature or new change was implemented according to their needs. So if you think about that, so Spline is kind of a documentation of Spark applications. It also is able to track dependencies like between jobs, and it creates, let's say, like an overall overview of the topology actually and how Spark jobs interact with each other. It also tracks details of each application. So actually, for each Spark application, you can see, let's say, what transformations are applied and how they transform your data. And also for each transformation, you can see what is the input and output schema. So before I start talking about the possibilities how to extend Spline for streaming, I would like to recap the basic concept that we did for lineage tracking of batch jobs. So if you are talking about lineage of batch jobs, is like tightly associated with the data set. And the lineage is kind of history, how data were transformed. And we leverage this information for Spark, from Spark execution plans, namely from the analyzed logical plan. So this approach that we have chosen has several limitations. So it only supports let's say, logic specified with Spark structured APIs, namely by Spark SQL, data frames, dataset, and datasets. And also, we are not able to reveal the details about the user-defined functions and Lambda functions that are passed into higher order functions that are defined on datasets, namely, for instance, map and reduce. So, Vaclav and I, we have developed a POC of the Spline that is extended, let's say, with the feature to track the lineage from streaming applications. And we tried, let's say, to follow the same approach. So actually, with batch jobs, we are able to leverage information, harvest information from structured APIs. So for streaming, we have structured streaming. So we follow the same way. But the lineage for streaming applications is like a bit different. Because for batch jobs, let's say you process it, you produce some data set, and that's it. But for streaming applications, it's a continuous process. Usually you have some destination, it could be Kafka topic, and you have, let's say, some Spark streaming application that is pushing data to the topic. But the lineage may evolve in time because you may stop your application, you may deploy new version, and the lineage of that application might be a bit different. So actually, when we are talking about lineage for streaming applications, we have to associate them with sources and within the time period. Now I will go a bit into details how we develop the POC. Actually, what features Spark offered to us. So we couldn't leverage the same entities and the same internals as we did for batch processing. But we were really lucky. In Spark, there is an entity called Streaming Query Manager, and it contains all the information about all queries that are executed within the Spark structured streaming application. But you can also write some listeners and subscribe to events that happened within the internals. So we did the same thing. We wrote our Spline streaming listener, and when your query is started, the streaming query manager sent to us, let's say, the event about the start. And also, since the streaming query manager contains information about the queries, it also contains the information about their execution plans. We can ask for them, and the streaming query manager returns their execution plans. But with our Spline logic, with our Spline streaming listener, we transform the execution plans into our internal Lineage model. We persist it in the Mongo database, and with Spline UI, then like regular business users can explore the logic. So streaming query manager also sent to us progress events. So actually, the progress event describes the information about a micro batch. So actually, usually every few seconds, the micro batch is executed and the progress event is triggered. So we leverage the information that are stored in progress event as well. And now you might start wondering why. So far, we leverage progress events for linking two streaming jobs together. So actually, when one producer is writing to a particular source, it could be Kafka topic again, and if we have, let's say, another one that is reading from it, we link those two jobs together if there are, let's say, writes and reads within the given time period. So for now, it was enough theory. We'd like to show you a quick demo. And actually, the demo is based on the task that I received from Vaclav some back in time. And he was really curious about the temperature and how it evolves in our hometown in Prague. And he just gave me like links to the meteorological stations, let's say to the endpoint that provide stream data. And actually, I spent some time, implemented the logic, let's say like with several Spark applications. And the logic was producing files with our temperature to some particular destination on HDFS. And after I gave him the file, he could produce charts like this. So I sometimes do mistakes, sometimes I'm tired. So actually, I'm not sure whether it was implemented properly by even myself. But Vaclav now will use Spline to reveal the details about the logic and try to understand actually what I did. Now, Vaclav, please use Spline to do that.
So, thank you, Marek. I really love your Meteo Station job. But what I hate is that I don't know what happened on 24th of September, and especially from 4 o'clock till midnight. And to answer this question, I'm going to use my favorite application. It's called Spline. The Spline UI is composed of 3 panels. On the left-hand side, there's a search bar. On the middle side, there's an overview panel. On the right-hand side, there's the details sections, which displays details about the selected nodes in the graph. So right now, I'm going to enter a selection into Spline of 24th at the beginning of the day. Right. And till the end of the day, so 24th. Speaking of the end of the day, and I'm gonna select the sink that I'm interested in, sink that gives me the temperatures in Prague. Clicking on the sink, the middle section displays a graph which represents Lineage. On the bottom, I can see that there's this Parquet streaming directory, which is named temperature Prague aggregate. And upwards, upstream, there are nodes representing sources or sinks and the jobs that process the data. As the ultimate origin, we can see that there are three ways how the data entered the Spark cluster. The first one, for example, here is a socket streaming. Then there's a Kafka and the CSV. Looking at the names, for example, here the Kafka, okay, you can see Prague.Karlov. I know that's a location in Prague, so that probably corresponds to one station. And these others, those will be probably the same. So looking downstream after these three jobs, there are another three Kafka topics. Again, I can see the names of the locations. Okay, definitely those three sources correspond to three different locations, three different stations. Now, however, I'm interested especially in the interval from 4 o'clock till midnight. So I'm gonna select that. And again, select my temperatures in Prague aggregate sink. And suddenly there are only two stations contributing. The data flow was different at the time. One of the stations was not contributing to the lineage. All right, but I'm still interested in details. What kind of transformations were used? I will start with the job upstream. It will be very similar to the other one, probably. Okay, I will unwrap these nodes. Source was Kafka, destination was Kafka. You can see there are some projections, so those will be just simple transformations. Okay, this is a serialization to JSON. And here we have another projection. Oh, okay, I can see the schema on the right-hand side. Some name, that will probably be the name of the station. Then we have longitude, latitude, temperature, pressure, and so on. Okay, I understand this one. This was just, it doesn't actually do anything, just some transformations, simple projections. Okay, I will go more downstream. Especially this aggregation job looks interesting. And how are these different stations actually put together? Okay, so there must be some aggregation. Okay, so here is a Kafka source. It reads from 3 different topics. As mentioned, we can see it on the details panel. Okay, some watermark, some filter. I don't really mind this. And then this aggregate operation that looks particularly interesting. So here I can see that there was grouping by window. The window is apparently 60 minutes, 1 hour. And then the operation, that's an average of the temperatures. Okay, so that was quite simple. Simple average on all arriving temperatures within given window. The issue was probably that there was one of the stations missing, so that caused some difference in the data. Okay. What we demonstrated now was a POC of the interval view, and that's the best we can do with the current Spark API, but it does have certain limitations. And for example, let's consider this case is an edge case. So let's have a job W2 which writes and ends before interval selection. Then there's a job W1 which starts within the interval which is selected and then continues beyond that. And then there's a job R which reads from topics that the both above write. And that one starts and ends before job W1. Well, in this case, actually, the interval view will starting from S1, then doing search upwards, would actually display lineage, which would contain job W1 and job R. They would be linked together in this manner. But that can't be right, because that can't be the real lineage. In this case, the data flow differs from lineage. This is edge case, as I mentioned. This is a delayed read and early write, and that's because job W2 was the one that was writing and the job R used, but it written before the interval. And job W2 actually written inside the interval, but after job R ended. So in this case, unfortunately, it's not 100% accurate. It's the best we can do, but this is the limitation. How we can improve on this in future? So the issue was that we used single interval and just timestamps on all the progress events. Instead of timestamp, we need to use different addresses of the rows of the progress events. And such addressing exists in structure streaming. Those addresses are called offsets, and they are present, they are guaranteed on each source in sparse structure streaming. And as well, in the progress events on the right-hand side, they are present in the progress event. For each source has give us information from where we read exactly on each topic, and after the processing, unfortunately, we don't know where it's written. That's not available. Even though that the most things actually will also be sources, thus, in principle, should be able to return offsets. How we can do better then? Let's consider on this diagram on the left bottom, there are only that we have three topics, but only offsets are displayed. There is no time considered. Let's select an interval on S1, and let's be interested in how these rows were written. All right, so you can see there was a single job R event that written those, and then the job R from its information read from S2 and S3 from these offsets. Okay, so let's do another search. And job W2 progress, okay, written there. I add it into the lineage. But then, okay, job W1 is not supposed to be part of the lineage, as we mentioned, but some different job X. So the principle is simple. The jobs are linked when the progress event offsets overlap, and we disregard timestamps completely. To conclude, Spline is a data lineage tracking tool. We are working on adding new support for structure streaming. We demoed the POC that is called interval view, and we proposed a generalization, and we are working hard on the pull request to get merged into Spark to get this better offset-based linking, the more accurate lineage. Our future plans are to release interval view into one of the next versions of Spline, and after our changes are accepted to Spark, in the cases where it will be possible to add this offset-based linking for firstly microbatch streaming and then as well continuous streaming. We have also other plans, for example, to support dataset checkpoints. If you have any questions, please ask now, or we are also available on the emails given on the screen. Please visit our GitHub page. The Spline is available there, as well as our other projects like Abris that was presented on this conference as well. So are there any questions?
First of all, thanks for the talk and a cool demo. I was interested in, you mentioned earlier that this Spline supports Spark SQL, like structure logics. So this was more like workflow provenance than data provenance, right? If I understood correctly. This is more workflow provenance than data provenance. Like using Spline, can I say, okay, this is the output record I have. If I track it, can it lead me to the bad input record?
Actually, we track it on the metabase level. So actually, we don't track lineage of each particular record. So actually, the execution plans describe the execution, and that's what we based on that level we define the lineage. So actually, with Spline, and also we live in a distributed environment, we can say, let's say, this particle record was kind of filtered out because of this, let's say, filter rule. So we just say, let's say, this is the flow of data, and those rules are applied.
Thank you.
Do you have any output API that allows to interface Spline with data cataloging applications or similar? Like if I have an application, I can query for given data set and get in response the related lineage.
Well, we have API where you can contribute to the project or implement it privately. There is a version that will be supported for some time, but we are planning to be changing some parts of the API. But if you would be interested, we would support you. We integrate Atlas at the moment and Hadoop storage, but we are not 100% sure that we will continue with Atlas. But yeah, there is interest.
Yeah, actually, I think, let's say, the question was, let's say, about how we interact with other tools and so on, right? And whether you can get, let's say, our lineage models, let's say, from our database or something like that.
Exactly.
So,
basically, my point is I do have a data cataloging tool in
actually,
my company.
You can check our previous talk from the previous European Spark Summit. But I would like to mention, actually, we have 3 persistence layers, let's say, for batch jobs. So the first persistence is to Mongo. This is utilized by the Spline UI. Then we persist lineage information to HDFS. It's just, let's say, JSON file. So actually, if you are able to understand the format of that lineage model, you can read it. And also we push data to Apache Atlas, and you can then combine it, let's say, with the lineage information from Hive, Apache Storm,
and within the documentation, basically, I can understand how to read the data from, I don't know, one of these persistence layers to eventually import in my application.
Yeah, it's like if you go to this link on GitHub, let's say there is documentation on how you can run some sample applications, also how to set up different persistence layers as well. Or you just write us an email, so we will respond.
Thanks for the talk. So is there any performance implication of using Spline? Or if you all have benchmarked, how do you benchmark the Spark job with the lineage tracking?
Yeah, actually, we did that. We wrote a scientific paper about this project that was published and in London and at international conference in Shanghai. It was an IEEE conference, and actually in that paper, actually we measured what is the impact of Spline. Let's say compared to comparing when you execute, let's say, your Spark job without Spline. But we harvest just metadata. We don't deal with data, so everything happens on the driver. So actually, we just take the execution plans, we transform them into an internal model and persist to database. But everything happens, let's say, in different thread because all the listeners, let's say, are executed by different thread. So don't be worried.
Hi, thank you for the talk. You mentioned the BCBS compliance. Now, I was wondering if you ever used this for traceability of Basel calculations, such as market risk, credit risk, counterparty risk, etc.
Yeah. So actually, this tool is like a part of our strategy. So actually. Yeah, so actually the applications, let's say, as you mentioned, from this area that runs on top of Hadoop, and let's say they leverage Apache Spark. Then, the usage of Spline is very simple. You just reference the library, and by one line of code you enable lineage tracking. and then everything goes to the database, and it's quite smooth. You don't have to do nothing extra. Just go to that link or see, let's see, our previous talk where I was talking how to use it.
Thank you.